All right, so here's an example of a two-sample t-test. Kimberly, that's me, grows tomatoes in two separate fields. When the tomatoes are ready to be picked, she's curious as to whether the sizes of her tomato plants differ. I underline that for a reason, between the two fields. She takes a random sample of plants from each field and measures the heights of the plants. Here's a summary of the results. Okay, so they're giving you, again, stats for field A and field B from, guess what? Two samples. So here's why we're going to run a two-sample t-test. Okay, so the average, the size of the tomato from field A is 1.3 with a standard deviation of 0.5. And again, the number of plants from that field is 22. Field B, the average size of the tomato is 1.6 with a standard deviation of 0.3 and a sample size of 24. So two different samples. Okay, so she does it randomly, and if we're worried about normality, again, here's why we kind of have a little bit of a permission to do this. I know, again, individually, this number and this number are not greater than 30, but combined, they are 46. So we do have something to kind of give us this indication that we're saying, okay, they're normal. And that is why, again, with means, we do a t value instead of a z-score. Z-scores, again, are saying they are most definitely, normal. Here we have an indication that they could be. Another way we could explain that or justify it is if we had data, which we don't really have data here, we have stats, we would be able to kind of see if, they were skewed or if they had any outliers. But again, we're just going to proceed with this. All right, so here's two samples. The null, remember, for a two-sample t-test, any of them, anything you answer, is saying that there's no difference. Like the average of field A and the average of field B, they're equal to each other. There's no difference, etc. Another way you may see that, and I did this again with proportions, I always showed you both ways, you can say that there was no difference. So the mean of A minus the mean of B equals 0. That is literally the same exact thing here. I just preferred these usually every time. All right, now why did I underline the word differ? Is, you have to figure out what the alternative is. And they're not really saying anything, but here, it's not like they're saying anything was greater about field A or lesser about field A. They're saying they were different. So again, different or differ is saying the alternative is they're not, in fact, equal to them. And another way you can write that is, again, we're talking about differences here. It's just saying that the mean of A minus the mean of B is not equal to 0. All right, here you see the answer. Let's see how we do this. Okay, in our calculator, we're going to go to the place we always go when we run a test, stat. We're going to scroll over to tests. I got to pull this up, my lights. And this time, since we do have two samples, we're going to scroll right past the t-test and go to a two-sample t-test. Sorry, I only have one hand. Okay, now here again, we do have stats. We have specifically the stats from the question itself. So here's what I'm going to do. Let me move. Okay, we're going to do field A first. Their tomatoes are 1.3. And then they deviate by, I can't remember, in the last 2 seconds I forgot. Okay, and that one had 22, yes. Okay, second one, field B, is 1.6, and then it had a standard deviation of 0.3, and that one had a little bit more sample size, and that's okay, it doesn't have to be the same, 24. We're saying they're not equal to. There's our alternative. Make sure that's highlighted because you do have options. We never pool. Don't you dare. You didn't pool in confidence intervals. You're not going to pool now in a hypothesis test. We're going to calculate that. And again, we're going to get these two things which are important. We're going to get T, which is our test statistic, and we're going to get our P, which is the most important thing. The difference of freedom, again, I don't even show that in the PowerPoint slides. You do not want to see that formula. It is insane. Okay, so with these two things, let's look at them on here. We have our test statistic, which is negative 2.44, and we have our p-value, which is 0.02007, etc. So that's what we're going to look at to determine what we're going to do. 0.02 is in fact less than 0.05. Now, if anything's ever less than, or your p-value, that is when we reject the null, the HO. We have sufficient evidence that the tomato plants in field A and field B, they differ from each other. So, the size of them, and what kind of gave us a little indication too, like why were we testing this out in the first place? I mean, look at the sizes between 1.3 and 1.6. They do differ in some ways. We just didn't know by, how much. Nor do we really know in this question. We just know that they're not, in fact, the same. So again, when we reject the null hypothesis, that means we are going with this. We're going with the alternative hypothesis. We have enough convincing evidence to do so. And there again is a 2-sample t-test.